This section is called compound inequalities. So up until this point, we have solved simple inequalities where you just could have variables on both sides, or you could have like terms on one side and you're moving it back and forth. But now we're going to be combining two simple inequalities. And we're going to be combining them with the words and, or with the word or. And the result of that is called a compound inequality. So, when we graph the two, there's one major difference. When you are graphing and compound inequalities, your graphs will meet in the middle. We're still going to worry about open and closed circles on the graph, where it'll be shaded in if it's or equals to, and it'll be open if it's not or equals to. Greater than is still going to go to the right, and less than is still going to go to the left. But if we have an and compound inequality, they will meet in the middle, or they should meet in the middle. If they don't, something went wrong. So let's look at A. Notice we have two separate inequalities. We are going to solve them the same exact way. So the first part, I'm going to subtract 1 on both sides. You see the word and. That tells me that this is an and inequality. Very important to bring down that word and I want to see you bring that down because that'll remind us, hey, this is an and not an or. As the problems get harder, they'll take longer to solve. It won't just be subtracting 1. So we want to bring that down. And on the right side, we'll subtract 1. Those are the answers we get. Now watch what happens when we graph this. So if I'm saying my 0 is here, and that's my 1, -6 would be here. We'll just worry about one at a time. So x is greater than -6, open circle, we're going to the right. Notice I didn't just put an arrow here. I'm kind of waiting for that. I just got the direction down. X is less than 1. Again, open circle. I'm going to the left. You can see what's going to happen here. They will meet in the middle. Ands meet in the middle. The reason we are saying the solution to this has to satisfy both inequalities. We need a number that is greater than -6 and less than 1. It has to satisfy both of them. So what number is greater than -6 and less than 1? Anything in here. That's why they meet in the middle. I'm a teacher and a basketball coach. I am both of those things. B. Okay, first I notice it's an and. Maybe you want to circle the ands or the ors right away. Still solving it the same way I would. Add 1 on both sides. Divide by 3. Notice I brought down the word and. Right side. Still going to add 1. I'm still going to divide by 3. And I get my answer. X is less than or equal to 4. Graphing it. Open circle on 3 to the right. Closed circle on 4 to the left. Again, notice they meet. They are ands. Now, the one tricky part about ands, and we'll have to do this, is they can be written without showing the word and. So you'll see in part C here that there is no word and there's no word or. It is still a compound inequality. How do we know it's a compound inequality? Because I see more than one inequality symbol. So if you see 2 inequality symbols, which I do here, and if you do not see the word or, it is an and. Now, very important how to separate these. You take the middle and you give it to the left side, and you take the middle and you give it to the right side. So here's what I mean by that. Starting on the left side, I have -9 is less than x minus 10. And then I stop because I already did the middle there. So you can think about doing it like that. That is one of them. And I'm going to show that and. I'm going to give the middle to the right side. So you can envision that like this. So notice I just worked from left to right. The inequality sign points the same way, and I gave the middle to both parts. Now I'm just solving like I normally would. Add 10, add 10, add 10, add 10. I get x is greater than 1 and x is less than 5. To rewrite ands in their final form, it's not very common that your answers will be like this, where you have an answer and another answer. You will see them in their final form written without the word and. The way we do that, we take the smaller number out of our answers. Pick the smaller one, which is obviously number 1. For and inequalities, your arrows will always be pointing left, to less than. And your variable will always be in the middle. That is my final answer. Look at what this is saying. There's 2 parts to it. This is saying x is greater than 1, and it's also saying x is less than 5. And that's exactly what it says above that. So that's the hard part with ands, rewriting it, splitting it up, and then rewriting the answers like that. Graphing it, you graph it the same way you would. Open circle to the right, open circle to the left. They're still going to meet in the middle. It's still an and, but just a little difference there. Okay, D. Is this an and or an or? This is an and. I do not see the word or, so it must be an and. I like highlighting the middle. How do I know it's the middle? It's in between the inequality symbols. And now rewrite it. Start with the left side. That's one of them. And there's the right side. Again, notice the middle went to both pieces. Solve like normal. And that's my answer. I'm going to rewrite it as one big inequality, compound inequality. What do? I take my smaller number first, which is -3. My arrows always point to the left. And that's my answer. We still have to remember when we multiply or divide by a negative to flip the sign. We didn't have to do that at all here, but just remember that. And also just know that the smaller number will not always be on the left side like it has been. Like here, the -3 is smaller, it's on the left. Sorry, let me rephrase that. It won't always be the first number you deal with. So like here, negative 3 is on the left, so it goes on the left here. Here, the 1 was on the left, so it goes on the left here. Sometimes your smaller number will be up here. And then you just have to remember, okay, put it here. So in your final answer, just to rephrase that, your final answer, your smaller number will be on the left. But when you do the initial splitting, it could be on the right. So just something to note. Graphing that. Again, I'm expecting them to meet. I'm remembering the filled in versus the not filled in, and there's my answer. The next page talks about OR inequalities. OR inequalities, the graphs will not meet in the middle. ORs, I'm sure you can imagine, the graphs will separate. They will go apart from each other. Why? OR inequalities, your answers will only satisfy one of them. I'm a teacher or I'm a construction worker. I'm only one of those things. I can only satisfy or make true one of those things. And that's what OR inequalities do. So if we look at the first one, we know it's an OR because we see the word OR. There's no tricks to ORs like ANDs where it can be written differently. If it's an OR, you will see the word OR. We solve both of them separately. So the first one, I'm subtracting 8 on both sides. I'm still bringing down that word, OR, just so I remember. And now watch what happens when I graph this. T is greater than -1 to the right, filled in circle. T is less than -6 to the left, open circle. Look at the graphs. They do not meet, they separate. That's what should happen for ORs. Think about the solution. I need a number that is greater than -1 or equal to, or a number that is less than -6. Could you ever give me a number that satisfies both of those? You couldn't, right? Because our answers are either to the right here or to the left here. There's nothing in the middle as an answer. If it was between those, that would be an AND problem. So that's the gist between ANDs and ORs. We'll do one more here. Notice it's an OR. I get x is greater than 7, x is less than or equal to 5. Again, notice ORs separate, and that'll always hold true.